Jai Hind. I, Shaurya Srivastav, along with my teammate Aditya, representing our school, Sunbeam English School Bhagwanpur, are here to participate in the ATL Marathon. Following the lines of the theme Mobility and Transport, we have our project here, which is the Overloaded Vehicle Detector.
Overloaded vehicle damage the road badly, putting many lives in danger. These drivers overload their vehicle for their own profit. Unfortunately, due to corruption, this is becoming a more and more common practice in our country. Thus, for this, we are here without suitable working model of our idea.
So let's say this vehicle is the overloaded vehicle. As usual, it goes through the toll plaza. This barricade, when detects a vehicle, opens and the vehicle is ready to go into the toll plaza. Now, we have a special speed breaker over here which has a special sensor which is called the load cell sensor. It basically measures the weight of the vehicles. So now, when the vehicle steps over the load cell sensor and if it is found overweight by the sensor, two things happen. Basically, the barricade up there goes down and secondly, the PI camera in the system is activated. Now this camera takes a picture of the license plate of the car and extracts these numbers from here. These numbers are important because it then creates a database of those numbers and sends it to the government as well as the overweight values as well. Now this data is also sent over to the next toll plaza. For example, in the first toll plaza, the vehicle overweight is asked to unload it in this overloaded area, without which this barricade will not open and it will not be allowed to run into the highway back again. Now let's say this vehicle overloaded itself again. At the next toll plaza, as usual, the vehicle goes into the speed breaker and steps over the load cell sensor again. If it is found overweight again, the data is already here in the database and also the comparative system works again and then we can find out that the vehicle has crossed its overweight limit 2 times in a day. And now the strict actions can be taken over the driver and his license can be exempted immediately. That is one of the best examples of the automatic function of this project. Now, this data is unique because it cannot be modified or deleted by any middleman or any user. So, it stays in the government records forever. This reduces bribery and corruption by a mile. Now, let's talk more about the system that we have here. We have used a Raspberry Pi 3 along with the Raspberry Pi camera because these are cost-effective equivalents to the actual cameras that we use in toll plazas. The Raspberry Pi 3 is a single board computer which is an IoT level enthusiast computer. It is power efficient and performance efficient as well. We have used it because it can power 5 to 6 multiple toll plazas at once using WLAN technology, and also we have tried to create this system as self-sufficient and power efficient as possible, meaning it can run off the grid when we use these power effective measures that we have created. For example, the solar tracking system that we have here detects the beam of light and actively adjusts its angle for maximum power efficiency. Also over here in the speed breaker, we have piezoelectric plates which convert mechanical energy of the vehicles into electric energy when vehicles cross over them.
Let us now discuss the future implementations of our project. This can be used for automated fines, dynamic toll pricing, customs and border control. It is an integration with Smart City initiative. This was all about our model.
Thank you and Jai Hind.